All right, welcome to Global Wind Systems again, but this is part 2 in Chapter 10, so let's get started. All right, so after today, or after this online lecture, you should have a better understanding of the general circulation and precipitation patterns, average wind patterns and pressures aloft, and an idea about the jet stream, what it is, what creates it, and where they're located. Let's think about how clouds form and think about what can cause clouds to form. And over our knowledge of the general circulation pattern of the three-cell model, where do you think clouds would form? Or I should say, where do you think clouds will not form, because we're looking for low rainfall, and they would not form in high pressure systems or where the air is coming down. Remember, as the air descends, it warms, and the air temperature and the dew point temperature will get farther apart, so there's less chance of condensation to happen. Well, where do the highs occur? The highs occur here in the highs occur here, right here at the pole. There are subtropical highs also here, because the air is coming down from the Hadley cell and the Ferrel cell. Another high here, and another high here. So again, this is a three-dimensional process. There's highs all over the globe at this point. Okay, so if you pull out a global map, what I want you to do is pull out a global map. There's several in the book, and look at these regions around 30 degrees in latitude and up in the polar regions, and tell me if you notice anything different about the climates in those particular regions. All right, so we get these subtropical highs in these polar regions, and again, the polar regions are very cold and dry. They are one of the driest places on Earth. Even though they are covered with snow, they are considered very dry. All right, let's talk about average wind flow and pressure patterns aloft. So when we're far aloft, all we have is the Coriolis force and the pressure gradient force. And we'll have strong pressure gradient forces, which will cause the wind to blow from out of the west. We call these geostrophic winds. And those occur north of the subtropical high. Well, and then in this, you also have causes the winds to blow out of the east, and these occur south of our subtropical highs. And these winds are usually stronger in the winter because there's a larger temperature gradient, and speeds increase with increasing height. Well, the farther you get up off the atmosphere, the farther you get off the surface of the atmosphere, you're going to have one of the forces is going to go away. I want to know if you guys can figure out which force will get smaller the higher we go up in the atmosphere. All right, so here's a picture of January, the winter for us in the northern hemisphere, but summer in the southern hemisphere, and you can see the general wind patterns aloft. They're all coming from out of the west, flowing towards the east here, and you've got some semi-permanent highs showing up and semi-permanent lows showing up there. And then if you look at the summer, now in the summertime, the sun is directly over the northern hemisphere, and you get these semi-permanent highs have shifted farther north, and you don't see any semi-permanent lows, but you definitely see the same wind flow, and there's a much greater pressure difference showing up in the southern hemisphere because now they're in winter, and the northern. All right, so that's what it looks like in the summer for the northern hemisphere, and the winter for the southern hemisphere. All right, so let's talk about jet streams. What are they? Well, they're swiftly flowing air currents, thousands of kilometers long and a few hundred kilometers wide and only a few kilometers thick. The wind speeds can be anywhere from 100 knots to 250 knots. And what is a knot? Well, that is the time. It's basically 1 knot is equal to 1 arc second of the Earth's radius per second. If you fly a plane or you're do a lot of sailing, you would know what that is. About 100 knots is about 150 miles an hour, and about 200 knots is upwards to around 300 miles an hour. So these winds really move. These winds are found in the tropopause at an elevation between somewhere between about 10 or 15,000 or 10 or 15 kilometers, and they move. They're not static in the atmosphere. They can move in 3 dimensions, up or down, higher in altitude, lower in altitude, or north or south, and so they can actually move around. And those are one of the major effects of what changes our weather patterns as these move around. Okay, so where do we get these jet streams located? Well, here's our 3-cell model of circulation patterns. We've got the North Pole right here, and we got our polar cell going on. We got the equator right here, and we've got our Hadley cell here, and then we have our Ferrel cell right here. And these jet streams occur right in the upper atmosphere in the intersection of those cells. We have 2 jet streams we normally see, one called the subtropical jet stream and one called the polar front jet stream. And you'll notice that the atmosphere is taller at the equator and lower in the poles. That's because we have warm air on the equator and cold air on the poles. And if you remember from the earlier chapters, as a column of air warms, it gets larger, and a column of air cools, it gets shorter. All right, so what we're going to do is go through an activity in class where you actually draw this out on a whiteboard or a piece of paper. And I'm going to recommend that everybody learn how to create this diagram, because it's going to show up in the future. All right, so here's another representation of a jet stream. I think this looks like maybe the polar jet stream here, but it's this ribbon of air that moves around the globe. It is a global phenomenon, and it basically shows the boundaries between all of these convective cells and mechanically driven cells that we see in the atmosphere. All right, so you've got your subtropical jet stream and you've got your polar front jet stream. The polar front has a tendency to split into branches, one called the northern branch and one called the southern branch. The other thing that can develop in these jet streams is something called a jet streak. There are regions in the jet stream that the wind moves faster than other regions, and so these regions we call a jet streak. We're going to find out in the later chapters these are going to become very important in developing and the development of storm systems that we experience on the surface. So here's the polar jet stream right here, and you can see that the wind speeds change. And then here's the subtropical jet stream. I should mention that this is the indicator right here that tells you how fast the wind's going in the direction. There should be an appendix in the back of your book that shows you how to read these markings. You don't need to memorize them, although you do need to find the appendix in your book, because you're probably going to have to use them in the future to determine the speed of wind you're experiencing. All right, so I hope you have a better understanding of the general circulation and precipitation patterns that can happen on the globe, the average wind patterns and pressure patterns aloft, and what a jet stream is. Basically what it is, what creates it, and where are they located. Okay, and I'll see you next time in part 3.